Light travels at 299,792,458 meters per second. Nothing can go faster. Einstein proved it. The cosmic speed limit, unbreakable. But what about darkness? Does darkness have a speed? And if it does, can it move faster than light? The answer is yes. Darkness can move faster than light, much faster. And it doesn't break physics. Before I show you how, hit subscribe if you love physics that breaks your brain. Because after we cover the speed of darkness, we're doing quantum entanglement, and that's even weirder. Now let me explain how darkness can exceed the speed of light, starting with a question most people get wrong. What is darkness?
Never heard anyone try to describe this dangerous, inconceivable force better than this. Most people think darkness is something, the opposite of light, a substance, something that fills space when light is absent. Wrong. Darkness is nothing. Literally, it's not a thing. It's the absence of things. Specifically, the absence of photons. Light is photons traveling through space. Darkness is space with no photons traveling through it. This distinction is crucial because when we say darkness moves, we're not saying something physical is moving. We're saying the absence is propagating. Here's an analogy. Imagine a row of lights in a dark room. All lights on. Now you turn them off one by one, left to right. The darkness moves down the row. But did darkness travel from the first light to the last? No. Each light simply stopped producing photons. The darkness didn't move. The light stopped reaching each position. Darkness doesn't travel. Light stops arriving. This semantic difference changes everything. Because if darkness is just absence, then it's not bound by the speed limit. Nothing is moving, so there's nothing to restrict. The shadow experiment. Now for the demonstration. Imagine a massive spotlight, powerful enough to shine on the moon, 384,000 kilometers away. You point it at one side of the moon, creating a bright spot. Now rapidly swing the light to the other side. The light beam takes 1.3 seconds to reach the moon, traveling at light speed. But watch the shadow. The edge of the shadow, the boundary between light and dark, sweeps across the moon's surface. How fast? Let's calculate. Rotate the light by 1 degree in 0.01 seconds. At the moon's distance, that 1 degree rotation moves the shadow approximately 6,700 kilometers across the surface in 0.01 seconds. That's 670,000 kilometers per second, more than twice the speed of light. The shadow moved faster than light. But here's the thing, nothing actually traveled. No photons, no particles, no information, just the absence. The pattern of no light here moved across the surface, but no physical thing made that journey. Another example, take scissors. Close them slowly. The point where the blades meet, the crossing point, moves from the hinge to the tip. That crossing point can move faster than the blades themselves. The blades move at normal speed, but the geometric intersection point moves faster. No part of the scissor exceeds its own speed, but the pattern, the crossing point, can. Same with shadows. The shadow is a geometric pattern, not a physical object. Patterns can exceed light speed. Physics allows it. So if shadows can move faster than light, why doesn't this break Einstein's cosmic speed limit? Because Einstein's limit applies to things, matter, energy, information. Darkness is none of these. It's the absence of things. And absence can move at any speed because nothing is actually moving. Here's the key. Could you use a faster-than-light shadow to send information, to communicate faster than light? No. If you're on Earth, shining a light on the moon, and you turn the light off to send a message, the person on the moon won't know until 1.3 seconds later, when the absence of light reaches them at light speed. The shadow moving across the moon's surface is meaningless to someone on the moon. They only experience the light turning on or off at their location, at light speed. The faster-than-light shadow motion is a geometric effect, not a causal effect. Cause and effect still propagate at light speed maximum. You can't send information faster than light. You can't violate causality. The cosmic speed limit applies to causation, not to geometric patterns, not to absences. Einstein's relativity is safe. The universe's rules are intact. Darkness can exceed light speed without breaking any laws, because darkness isn't breaking anything. It's literally nothing. The light cone. To understand this deeper, we need to talk about light cones. In relativity, every event in space-time has a light cone. The future light cone, all the places light from that event can reach. The past light cone, all the places light could have come from to reach that event. Information, causation, is confined to light cones. Nothing can cause something outside its light cone, but geometric patterns, not confined. The shadow on the moon moving faster than light doesn't violate light cones, because no information travels from one part of the moon to another. Each point on the moon is independently either receiving photons, light, or not receiving photons, dark. No communication between moon surface points. Each location independently experiences light or dark based on whether photons from Earth reach it. The pattern looks like motion, but it's not causal motion. It's correlation without causation. Another way to think about it. Imagine a row of light bulbs connected to one switch. You flip the switch, all bulbs turn on simultaneously. Did information travel between the bulbs? No, they all responded to the same external cause, the switch. The shadow sweeping across the moon's surface is similar. Each point responds to the light source, not to neighboring points. Pattern without propagation, motion without movement. This is why physics allows it. So what does the speed of darkness teach us? That reality is more than things. Physics focuses on objects, particles, forces, energy. But the universe also contains absences, empty space, voids, nothing. And these absences follow different rules. Speed limits apply to things, not to the lack of things. This has deeper implications. In quantum field theory, even empty space isn't truly empty. Virtual particles pop in and out, vacuum fluctuations. The void is active. Understanding what nothing can do is as important as understanding what something can do. The speed of darkness is a reminder the universe's rules govern existence, but absence has its own logic. Darkness doesn't need to obey light's rules, because darkness isn't playing the same game. It's not a player, it's the absence of players. And that makes all the difference. If this broke your brain, you're gonna love what's next. Quantum entanglement, where particles communicate faster than light. Sort of. Hit subscribe, because reality is about to get even stranger.